first of all, we have Laura from the University of Ghent, who is going to be presenting the first one.
Thanks a lot for having me. So I would like to talk about the process or project that we had at Ghent University over the past few years, trying to be able to offer a centrally supported ELN system at the university. So now you can also see I'm a data steward at Ghent University, part of the university library, part of the open science team, in fact. So as a data steward, I was asked to represent the researchers in the process of selecting an ELN for the university. Now, on the next slide, you will see the two routes that we chose to take. That was, on the one hand, to come up with a more generic solution. And since we're using the Microsoft M365 environment for data storage, we have designed a SharePoint template specifically to hold data from research projects, but also the documentation. So using that as a note-taking tool. And in parallel, investigate the possibility to get a university-wide license on what we then called a professional ELN. So that's an ELN that will effectively replace the official paper lab notebooks, and that will meet all valorization criteria the way they're being put forward through regulatory requirements like the FDA 21 CFR 11 and from a valorization perspective, so to demonstrate inventorship and ownership. Okay, on the next slide, there's an overview of the different stakeholders that we identified. First and foremost, management, who's in charge of making sure that there's a budget available. If we would not have had a budget allocated, we would not have been able to drive this project. There's the researchers who are very important. They will be the users of this solution. The research support staff, where we also count ourselves as data stewards to support the researchers and to connect all the different dots. It was clear from the start that we needed external collaborators to be able to access this system, but also that the system needed to be compliant. Again, valorization, tech transfer, but also IT requirements, privacy requirements were extremely important. So we needed representation from all these different stakeholders in the project and during the requirements gathering. On the next slide, you see the very, very short summary of what this requirements gathering resulted to. That is mainly that it should be efficient for researchers. They were looking for good search functionality, structured reporting, so they want to be able to access the information more quickly. But only in very rare cases did the research teams themselves acquire a license because of the cost of these systems. They also did not want to completely replace paper. They thought that paper lab notebooks were complementary to a digital environment. Yes, on the next slide, I'm zooming into what we did throughout the process to end up with a professional ELN. So we had focus group meetings, requirements gathering, exploring partnerships as well, because there's the university, but we have a university hospital. We have strategic partnerships with the Flemish Institute for Biotechnology, for instance. They also need an ELN. So we were exploring whether or not we could get a software together. That turned out not to be the case. So we started a formal tendering procedure based on the requirements that we gathered, which allowed us to select in the end RSpace, who won the tender. We started implementation early 2024. And then since October 2024, we rolled it out university-wide. So opening up beyond the first initial testers and early adopters that we had on the system. On the next slide, you will see that we chose to implement this as software as a service. So it's hosted by the software provider. So the burden on our IT team is quite limited. We implemented a control step in the sense that not everyone was free to create lab groups, they're called, so the research teams. They need to request one of those. And we saw that in the 6 months that we're now operational, there's 500 users registered and 75 lab groups have been created. I would say that about 1/3 of them are already using it routinely, 1/3 is exploring, and 1/3 simply created a group and is exploring the tool, or at least I hope so that they will be able to start using it more in the future. And that's it. Looking forward to discussing this approach.
Cool. Thank you ever so much.
Okay. Right, let's make this quick. So, a little bit different. I'm here talking about the Open Reaction Database. Maybe, you know, thinking about the common experiences here. I have rolled out ERNs at Imperial College. And now I work at the Open Reaction Database as a consultant managing the project. So we're interested in chemical reaction data. And so in here, you know, if you're a chemist, you look at this, it's all very familiar. There's a lot of information there encoded in our chemical scheme, and we have this kind of method text. And, you know, historically, you would do lots of scribbles in a paper notebook and then get to a paper and you'd formally document it like this. One of the problems with doing it this way is a lot of information is contained between the lines. It's the knowledge that the chemist has and doesn't get written down. And you've got to really learn that and understand what's not been said. And so this causes problems if you want to think about having algorithms and using machine learning. A lot of that knowledge is not documented. So what we're doing with ORD is trying to act as a bridge between experimental groups and machine learners. And so that's why we've come up with this structured schema to really try and, you know, support that. It's had a lot of input from high throughput experimentation laboratories. You know, I think one of the speakers this morning was talking about high throughput. That's one of our strong areas, and industry as well. The strength is in the schema. It's you know, this is the top level of the schema, and we're capturing in a very structured way all the very important parts of the chemical reaction. And then the idea is you have structured fields for the most important things. Very few of them are mandatory, but we try and provide a place to put things. And then recognizing that you can't cover everything, there's then additional details fields that allows for that retext description. So we're trying to cover both scenarios. It all lives on GitHub, and we have a public repository as well, where you can go and search for the publicly available data. It should say we're all about open access, and we mean open access for everyone. It's licensed in such a way that you know, you can use the data to do research. You're a company, you want to use, you're an electronic lab notebook, and you want to use some of these tools. You can grab bits of our software and use it. We're a consortium. We're not about trying to make money out of this. We just want to try and help, you know, communicate data better in this field. And so thinking about the conversations today, there's been a lot of talk about that tension between having a generic system that suits the whole university and a very focused system for particular domains. And chemistry is one of those ones. It's my domain. We want very structured data. So there are, you know, you can imagine a future where you have a very generic ELN, ERN type system. Then you have something like ORD tacked on the side that allows those very specific groups to put structure on their data and then download a file and put that in their ELN. So I'll just put that out there, and then we have releasing in about a month our new app for putting your data in. So this, I say it's ELN Lite. It's not an ELN, but it's a very structured form, very recognizable to a chemist. Bit different to the rest of the talks today, but I'll put that out there. Happy to talk to anyone. So, yeah.
Oh, very much like before. So next up we have Philip. Should
So hopefully this should also be a quick one because this is more of a what we've done as opposed to going into any real depth. There's some other background for it. So Southampton University teaching labs. Sometime before COVID, they changed what they wanted to teach, what they wanted notebooks to be within the labs. Went paperless, and then something between lecturers not having time to put things into place and COVID meant that nothing was ever put into place. So there were no lab books, really. They got rid of paper, but there was nothing to actually record anything on. So students were using a mixture of whatever they could. And due to a overheard conversation in a coffee room, PSDI got brought in, we did some work together, and basically I ended up being the person who the time for lecturers could fall back on me to actually sort of put this thing into place. So there was lots of discussion with the staff was needed. We used Blackboard and Blackboard Ultra at the University of Southampton, which was very useful because you can just set up a Teams through Blackboard or Blackboard Ultra for whatever given module. Within that Teams, you can then just create the notebook. It pulls in all the students, and it's kind of there, which takes a lot of the administrative sort of weight out of things. Because if you had to go and put 150 students into a sort of one note manually, it would be a pain. And then you won't have to do that. And that was sort of one of the initial sticking points. Chat with the staff, correct with the template, actually took on board some of Keris's stuff from her papers about things. So we had titles and questions within those. Some things are added by staff down the line. And then to sort of go with your sort of the tables and bits and pieces, we actually created a separate page which had things like reaction tables, and then a whole bunch of documentation on how to add chemical notation, how to add equations, because OneNote doesn't natively support any of that. And the idea there was because it's a teaching tool, we didn't want to put things in there because if a student had a paper notebook, they would have to draw a table themselves. You don't just give them a copy and paste table to do it. The aim is for them to think about what we're actually doing, because in some of the labs, some of sort of the sort of more computational stuff, they don't need to put one of those in. So it's getting students to actually think about what they're doing, not just blindly copying. And the last thing with this, the university has hardware in the labs. We have something called LabSafe. So there are enough laptops that all students can use a laptop in the lab without having to bring their own equipment in, which is great because it means that A, no students are locked out due to not being able to afford their own equipment. And secondly, you haven't got any of the contamination issues that you might have with taking things in and out of a chemical laboratory. So we start with the negatives and then go to positives at the end. OneNote has 3 different versions on Windows OS. It has a web-based version, it has a Teams-based version, and it has the actual app on the computer. They all do slightly different things. So for example, the web-based versions, the Teams versions don't have the sort of Microsoft equation editor. You can see them, but you can't write those equations there. But some of the setup, for example, on how to do things and some things you need to change if you want to push it out to students, you can only do on the web-based version. You can't do the Teams version on the. So there were, that's the thing. No inbuilt chemical notation. This was really awkward for some of the students. This is one of the things they genuinely disliked about OneNote. We have ChemDraw, so it was pulling things out and getting to the but there wasn't that integration, and Microsoft don't seem particularly bothered in having any from the chemical integration when they don't actually work at me. We had syncing issues. People lost entire labs worth of data just because they were using the Teams version, and the Teams version wasn't keeping up. We did tell them to use the sort of app-based version. Their students, some of them didn't listen, and there were issues, but it's still a problem. So although sort of we tried to mitigate that with telling people that, they didn't do that. And some of the students gave us a little bit of pushback from, they want to use different pieces of software because that's what they used in at school or in their personal life with bits and pieces. So there is that, what is the best for everybody? However, there are lots of positives with it. It was easy as up. As I said earlier, we basically pressed some buttons, and actually it all formed itself and it existed, and it put all students' data, all the bits and pieces. So we didn't have to faff around with trying to get people into there. It's great for teaching. I know Samantha brought up earlier about who is the target audience for the ERN or the ERN that you're implementing. It's really simple. What we're actually trying to do here is get students to learn how to take lab notes, having some flashy, fancy ERN is not actually going to help them. They're just going to get more confused by all the different bits and pieces in there. Having a page of stuff that they can just write in is useful. Minimal software and hardware requirements. So these are on slightly older laptops now, 5 or 6 years old. It still works fine. Yes, there's some linking issues, but actually, broadly speaking, there aren't massive slowdowns. Accessible outside the labs, so all students can still access their notes from wherever they are, even if they're not on those same laptops. You can search it, people can go through it. And they can add images, yes, and files and link data to it, which is really good for some of their Spectrum and NMR stuff, so they can actually put the thing straight in there. The downside to this is that at the university, they have banned phones in the labs. So we cannot take photos and put them straight in the lab basically. And that's it. Broadly, it's been a success. It's been trial, well, I say in trial, we implemented it in the beginning of the year. Still to go through the questionnaires, but yeah, it's worked, broadly speaking.
Thank you very much for everybody for doing lightning and staying lightning.